Okay, let's get it started up here. Just want to introduce myself real quick. My name is Michael Jackson. Thank you. I'm a computer programmer. I recently moved actually down to San Diego area, so I'm super stoked to be here. I lived in the Bay Area for, 6 years, and then I was like, this sucks. So I came down south and really enjoying it. We live up in Carlsbad, my wife and I, and our 4 kids. We have 2 boys, 2 girls, 10, 8, 4, and 1 plus something. So we have a ton of fun with them. So I just want to thank Chris for inviting me to be here tonight. I just by way of introduction, I'm one half of a business called React Training. My partner and I, Ryan Florence, we work on a lot of different open source React code. We wrote React Router 2 years ago, right as React was kind of taken off. And it was a tool that a lot of people use to kind of, start building full page applications in React. At that time, I don't really remember a lot of people using React. In fact, I think probably the only people that I actually saw who were using it, I think Netflix was using it at the time. I think Khan Academy was using it at the time. But you didn't really hear about it a whole lot. And I think it wasn't very popular, primarily because of the JSX, right? These little angle brackets. It's like, what is this XML doing in my JavaScript, right? How many people thought that kind of the first time they saw it? Yeah, totally. Yeah, don't be ashamed. It's okay. I thought that too. And so, we were kind of working with a lot of different technologies at that time that React came out. And so we started using React and we started thinking, hey, React is really cool. It took us a long time to figure out why we thought it was cool, but all we knew is that we had a lot of fun when we were writing React. Has that been your experience as well? That it's like, oh yeah, like, I remember this. I got into programming because I enjoyed it. Because I thought it was actually fun. Like, call me a nerd, whatever. I thought it was fun to like make applications on the computer. I thought it was cool to, click around and make games and like just do stuff, create a web page for myself. And then I found myself in this place like 3 or 4 years ago where I wasn't really having very much fun anymore. It was, programming in browsers has always been kind of tricky, and especially when browsers, Firefox became popular, and then Safari, and then Chrome, and then they forked it, and then now it's Blink, and so now you've got all these different platforms where you got to try and make your code run. Let's caffeinate, so that doesn't happen again. And coding really wasn't a ton of fun. So when I got React, I got really excited. And so when Chris asked me to speak tonight, I thought, I'm just going to talk about how fun it is to do React. I'm just going to try and bring back some of that fun aspect and just build a cool little app with it. But anyway, I'm half of this company, React Training. We work on a lot of open source React stuff. I contributed the code. So we actually go around and we do trainings, and I put into this repo, the React subjects repo. This is where we keep all of our training materials. So all of our training material is all open source. And I put in a new example, a new exercise into this repo earlier today called the calculator. So about a month ago, I was kind of sitting around and I was like kind of bored one day. And I just thought, I was looking at my iPhone and I was looking around and I was thinking, it'd be kind of fun to do one of these apps on my phone in React and see how I could do it. And so I rebuilt this little calculator. Might be familiar to you, right? This is our nice little friend. I remember the first time I saw this calculator, I was like, that is so ugly. Because it was when they went to all the flat stuff, remember? How many people got super panicky when Apple ditched all the skeuomorphic stuff? I remember sitting in my little apartment in San Francisco just like, they don't get it. Apple does not get design. I get design, and I know those big puffy skeuomorphic icons are way prettier than all of this flat stuff. Yeah, I think that's My good friend Michael here is sitting in the front row, and we had this conversation last week where we're like, we all just react that way. When anything changes, it's just like, we hate the change. And then a year later, we're all good. We're fine with it. We're good. So anyway, so it's a cool little app. It doesn't do anything, though. It's lying to us. It's beautiful, but it just doesn't do a darn thing. Well, let's check out the source. If you are following along, go ahead and open up subjects, calculator, exercise.js in that repo. If you're not, no big deal. Just follow along up here. So you can see the source code for this calculator right now. It's not terribly complex. It's just a bunch of divs and buttons, in fact. So I took all of the hard part and did it for you. All of the HTML and the CSS, and I did it for you. I'm going to pull up a tweet real quick that I love. This is a tweet from a buddy of mine. I'm on the fence about React. Its huge productivity gains mean I spend a way bigger percentage of my time writing CSS. It's true, right? How many people love writing CSS? Yeah, okay, a few. I've never personally actually written CSS where I don't go afterward and be like, this all needs to be rewritten. Like, who wrote this? Oh, it was me 10 minutes ago. So what I did was I went ahead and I wrote all the CSS for you, so you don't have to worry about any of that stuff. And I wrote all the markup, but it doesn't do anything. So how can we kind of bring this thing to life? How can we make this calculator actually work? So let's see if we can do that. As we go through this exercise, two questions that I always keep in mind whenever I'm doing a React app are, one, what state is there? And two, when does it change? I've found over a couple years doing React that no matter what problem I have, like no matter what it is, if I can reduce the problem to those two questions, and I can answer those two questions, what state is there, and when does it change, I can use those two questions as a framework to think through any UI problem that I have with React. So let's apply this to our calculator app. When you look at this calculator and you click a button, for example, what state is there? Any idea? Like, what would you call that? Like, you entered something, right? So this number, if I hit a 9, this number should now be 9. It should not be 0, at least, right? So that's part of the state of our application, right? I'm going to scoot this over a little bit. Pop this up here. So I'm actually just going to model that state. So the way we model state in React components is we just have a little instance variable. So if you're not familiar with the ES6 syntax, we could actually do this whole thing as, actually, let's just do it like that. Const calculator equals React, create class. How many people are more comfortable with this syntax? People are like, no, do the ES6 classes. Okay, we gotta have a vote. ES6 classes, create class. Wow, all right, fine. You guys like the instance property initializers? That's what we got here. So we're saying state. What should our state be? Well, I'm just going to pull this little value right here, this little string here. I'm just going to pull this right out of my UI. Oops, not that. Jeez. And then I'm going to show how inept I am at Vim. There, I'm going to put that 0 there. Just going to pull it out. I'm going to keep this thing in state. Okay, so nothing's actually changed yet, right? But at least I've got this value in state, so now I can kind of manipulate it kind of dynamically. So notice we've answered our first question there. What state is there? Well, we know that we've at least got one piece of state. We're calling it the display value. And that represents the value that's going in the display. No rocket science there. So now when I hit one of these keys, I want to update that display value. Let's start up here, for example. So I've got a button here, so I can say on click equals this dot input digit, and we'll say 0. Actually, I'm just going to do this. Click equals, and then that'll be a 1. Let's see, so this will be 2, 3, 4, 5, 6, 7, 8, 9. Let's have an input digit. I like to call these methods my state changers. And they answer the second question. When does my state change? Well, all of these kind of event handler methods, those are the things that change my state. So when somebody hits a digit, I want to update my display value. So I know I'm going to have a set state in here. So this is how we update our state in React. One of the things people say that there are a lot of cool things about React, right? Like the virtual DOM, server rendering, things like that. To me, one of the coolest things about React is this separation of state from its representation in the UI. That's what really, really makes it fun for me. So I don't have to worry about twiddling DOM elements anymore. I don't have to worry about going to the DOM, adding class names and stuff like that. All I have to do is set state and let React reflect the change to the DOM. So here I'm going to set state. I'm going to set my display value state. And what should it be? Our display value state is a string, right? So maybe it should just be a string of that digit. Let's try that. 9. That works. Oh, it's a lame calculator. Can only add single-digit values. How should we change this here? Append it to the previous state, right? So maybe if I'm actually going to work through this one. So I'm just going to say display value plus the digit. And because this is JavaScript, we can add strings and numbers. That's cool, right? All right, let's see if this is going to work. I got that dumb leading 0. All right, hold on. We'll figure this out. Oops. If the display value is 0, let's just use the string of that digit. Otherwise, we'll append. So if it's 0 and I hit the 9, then it should just be a 9. And then now if I hit the 6, I should get 2 numbers there and 3 numbers and 4 numbers. And the display is horribly broken. We'll address that one later, hopefully. Okay, so you see kind of how we think through this, right? It's like, what state is there? When does it change? When they make that change, we get the opportunity to consider the whole state of the world right now. Our state is the string 0, new digit coming in. How does that affect the state of my little app that I've got here? Okay, so let's keep going with this. So inputting digits, that's easy. What about this one? What about inputting this little period here? I'm going to have a method called input dot. So how is this going to affect the display value? Remember, we get to consider the whole state of the world right now. We know what our current display value is, and we know the dot is coming in. So I would suggest that we kind of think about this for a sec. So it doesn't make sense to have a number with 2 dots, 2 decimal points, right? So maybe we should only do something if we don't have a decimal point. Display value index of decimal equals -1. So we'll guard that set state call inside there. Does that make sense? right? Only if we don't have a decimal value, then we're going to do something. Maybe we just set the display value to whatever it was plus a decimal. Does that seem like a reasonable change to make to the state? So now if I say 9.3 point does nothing, 6, 5, that's pretty cool, right? Like, we make changes. What about this guy? This little button. That's annoying. It's not working. Let's see, clear button. On click for this one, let's say, I just realized my font is really small. Is that better? On click for this one, let's say this dot clear the display. If anybody's wondering, this is actually how I code my apps. I start with the HTML and all of the CSS stuff, and I'm like, okay, looks good. Now let's add the behavior. It's actually kind of a fun way to do it. Okay, so if I want to clear the display, that's a really simple set state, right? Display value 0. So I could punch in stuff, and I could punch in decimal points, and all that stuff works, and then I could just say clear, and I get back to 0. Not bad, right? You see kind of how thinking about things like this as what state is there, when does it change? Let's tackle these two function keys up here. Plus and minus and the percent ones, because these ones are kind of easy. So let's see, plus and minus is here on click equals, we'll just say this dot toggle the sign, I guess. A method we call toggle sign. And the goal of this thing is just to, if it's got a negative in front of it, put a negative. If it doesn't, no, sorry, other way around. If it doesn't have a negative, put one there. If it does, remove it. Just going to grab some code from up here. This dot set state. It's just another state changer. So I guess I'll do display value dot and let's see. I can do car at 0 equals a negative. Is it a negative? Yes. Okay, then do the display value. I literally have to, whenever I do a ternary, I have to ask myself a question. Like in that question voice. I have to say, is it a ternary? Yes. Okay, then do this. Otherwise, no. It's just a limitation of my brain, I think. Okay, ternaries are not my friend. I think that makes sense. Does that make sense? So if I say 9, negative, psych. Oh, wait. It's not working. Why isn't it working? Display value substir 1. So if the first character is a negative, yes, then remove it. Thank you. Thought this guy knew JavaScript. Negative, psych, negative, psych, negative. Okay, let's make this percentage one work. Let's see. Doop. On click equals this dot, what should we call this state changer? Input percent. At this point who's thinking, are we ever going to use numbers? This is a calculator, right? Like we're just manipulating a string. That's kind of silly, right? What state is there? Like the only state that is changing in our app, literally, as we're pushing buttons on this calculator, is there's a string that's changing here in the display. All right, so we don't have to get too fancy with this. Not yet. Like, it's totally working, according to me. Does anybody think this is busted? Like, it's just a display value. This guy doesn't know what he's talking about. All right, so the display value, if I'm doing a percent, I'm actually going to cheat here. I'm going to just say the display value is, and you know the Apple calculator cheats here too. They don't actually like put a percent sign. They just divide it by 100, which I think makes a lot of sense. So we could say the actual value is parse float, the display value. Hey, there's a number. We're going right back to string, baby. That's where we like to be. Because that's the only state that really matters. Right? That's the only state that we have right now in our app. So I could say 63% point. Oh, nice. Like, this stuff all just works right now. 63% negative, positive, negative. So if we can think about these changes, a button click, what change does that have on the state of my app? What changes does that make? Okay, those are kind of the easy ones. These ones down here are kind of the weasel keys. These are the hard ones to deal with, right? These are the operator keys, right? I'm looking at these orange buttons down the right side here. In these ones, now that we've had some practice thinking about what state is there, when does it change, these are gonna kind of throw us for a little bit of a loop. But if we're careful and we think about what state is there and when does it change, I think we'll get through it. So I need some event handlers here, right? On click equals, I could say this dot perform operation slash. I'm just going to give all of my operations these kinds of like character representations. So this one is well, let me put all these here first. There, and there. Okay, so this one is an equals operation. This one is a plus operation. This one is a subtract operation. This one is a multiply operation. Just need some event handlers, right? So perform the operation, and the argument here is the operator. Okay, I want you to think now. If I'm in a calculator app, and I click some buttons, and I click, and then I go over here and I click one of these operator keys, what state is there? Yeah, there's a pending computation, right? 96.3 times what? Right? We're essentially waiting for the next number to come in, right? We're waiting for, okay, times what? Should we update the display? Let me ask you that. I heard yes and no. If I hit that times key right now, would you expect the display to update? The 96.3. You would? It's up to you, right? Yeah, you could put an X after it. The way the calculator app does it is they just they indicate, I should maybe have my calculator app plugged in. They indicate that the multiplication operation is selected, but they leave that number value in the display. So it's like you see the number value, you see that you're about to multiply, but that number value is still just sitting there in the display because you haven't told it what to multiply by yet, right? So if we think about these things in kind of this piecemeal way, I think we can figure this out. So what I'm going to say is there's going to be a new piece of state called waiting for operand true. Is that going to update the display in any way? Not really. Like, all we know now is that we're waiting for an operand. It's kind of interesting. I'm going to put it way up here. Waiting for operand. I'll say by default it's false. Okay. And I'm also going to put this operator that that they selected, I'm going to put that in my state as well. Because the truth is, now that I've hit this number, and then when I hit multiply, I'm going to hit another number, and then I'm going to hit equals, and I need to remember that I hit multiply the first time around, right? So I'm going to store that. I want to keep that. So I'm going to have operator. So what state is there now? Now we've got a display value. Now we've also got these two pending states. We are waiting for an operand, and by the way, here's the operator that they selected. Anybody ever do this? This is my poor man's debugger when I can't afford a real debugger. Oh, come on. This is why I hate CSS. Calculator. Where's my calculator? There we go. You have a background, right? Not anymore. Okay, there's my state. And now my buttons look weird. 96.3 times. Check it out. I've got new state. Display value didn't need to change quite yet, right? But I know that I've got new state. I seriously use that trick, by the way. Okay, we're not going to use it now. We're just doing that so we know that our state is changing. So how does this affect the other keys, though, now that we have... So basically what I want to do is I want to say, 36 times 3. Well, that's not what we want to see, right? After we hit the times key, we want to see new numbers appear in the view, right? In the display value. Let's go back up here to our input digit function. I think this is going to have to change a little bit. Instead of just saying, okay, it's either a simple append or a replace operation, right? Now we need to know, are we in that state where we're waiting for a new operand? If so, just wipe out the previous display and replace it. Otherwise, do the append thing, right? Some people are like, I just wanted to come to a meetup and drink some beer, and this guy's making me think, and I don't know how I feel about that. These meetups used to be so easy. All right, so if I'm waiting for an operand, now what am I setting in the state? Let's walk through it again. 36 times digit key. How does that change the state? Yeah, so we got the old value has got to. We might have to save that thing off somewhere, right? What about how's it going to change the display value? Yeah, the display value is just going to be that new number, right? So let's say display value is going to be just string of that digit. Oh, by the way, I think we're going to say, just going to take a peek at my notes here. Input, yeah, we have to say waiting for operand. False. So at every step of the way, we're basically going to say, how does this change affect my state? They're putting in a new number. Am I currently waiting for the operand? Nope. I'm getting it. They're already putting it in. We're going to do that here in our input dot method as well. Let's think about that. So if I say 36 point times 0.3, for example, right? Point could be the next thing after a, it could be the beginning of a new operand. Let's try that. 36 times point, oop. How did that change? Let's see, 36 times point. Okay, what state is there? When does it change? Anybody tell me where my bug is? Sorry, I didn't hear you.
The waiting for operand and input digit is not represented in input dot.
So the waiting for operand and input digit is not represented in input dot. I don't know what you mean by that.
Same logic, yeah.
I need the same logic here as I've got above. In the back, any ideas? If I'm waiting for an operand, here, let's do this. This is what you guys are saying, right? So if I'm waiting for an operand and somebody hits the dot, at that point, clear the display, right? And just set it to be a dot. Let's just join these two lines. (36 times 0.69). Awesome. So it's really cool how we can just sort of consider the entire state of the world as it changes. I'm going to take a brief time out here because we've been doing some heavy thinking. There's a man by the name of Dijkstra, really famous programmer from back in the 60s and 70s. I love this quote of his. Our intellectual powers, he says, are rather geared to master static relations, and our powers to visualize processes evolving in time are relatively poorly developed. For that reason, we should do, as wise programmers aware of our limitations, our utmost to shorten the conceptual gap between the static program and the dynamic process, to make the correspondence between the program spread out in text space and the process spread out in time as trivial as possible. So what he's saying here is, like, there are two versions of your program, essentially, right? There's one that's spread out in text space, in your editor, in Vim or Sublime or whatever. And there's another one that's spread out in time that's actually running. And sometimes those are two very different programs, right? What's actually running in the browser or what's running in the app as it's running is not acting like you thought it was going to when you actually wrote the code. And so what we need to do is there's a gap there. We call that gap bugs. And so what we need to do to try and close that gap is to make it really easy to just sort of read our code and predict at any point in time, I can read that code and I can predict exactly what the UI is supposed to look like based on the representation in the code. And so what I find is that separation of state that React gives me, that separation of state from its representation in the UI, actually helps me to reason through my code really clearly and close that gap. Okay, so let's keep going with this. So let's go back down here to I think our display values are all good now, right? So if I clear 89.3 minus 6.2, whatever, oh, sad face. The equal sign doesn't work yet. Okay. So that's got to be here in our perform operation, right? That's the function that we're calling when the equal sign gets hit, right? It's time to do some math. Now, we've got a lot of different states that we can be in here, right? So far, we've actually got 3 pieces of state. We're going to wrap this all up. So we could say, I'm gonna model all of my operations here. So because there are lots of different types of operations that can come in, right? So we're gonna have to, I wanna model them here so we can avoid writing a massive switch statement. So I'm gonna have a function, basically a bunch of functions that know how to do these operations on numbers. Pre-value, next value. So if the operator is a slash, I'm just gonna return pre-value divided by next value. If it's a multiplication, I'm going to do some multiplication. I can do plus, and I can do minus. Minus, and then here I can just, so if it's an equals, and I've got a previous value and a next value, I'm just going to return that next value. And hopefully this will make sense in just a little bit. Okay, so I guess let me ask you real quick. How can we think through this? We know what state we have, right? At least we know the next value in this case. The next value is just going to be this parse float of our display value, right? We're just going to pull the thing out of the display, parse the float, and now we've got a number we can pipe in here. So we could say, const computed value is going to be, sorry, I'm going to move these up. So our computed value is going to be operations, operator, call that with the previous value and the next value. Okay, so how do we get our previous value? Oops. Somebody said it earlier. Yeah, I gotta save it, right? So earlier I was like, I'm gonna input this operator. And this code isn't going to run because this one's not going to run either. Let's go back to the UI. So when we made this change, when we say like 96 times, and now I'm waiting for operand true, right? I'm waiting for this next operand, which means on the very next hit of a digit, that display value is gone, right? We've lost it. So we should probably save it right now because we know that we're going to need it at some point in the future. What does that mean we've got? More state. You nailed it. Let's call this state like our real value, I guess. So we've got a display value that we're actually like just keeping in the display, right? That's just a string. And then we've actually got like this real sort of internal computed value, right? And so you can type in numbers, and then you can type in more operations and more numbers and more operations. And based on what operation you do, you're just compounding that new operation on top of the previous value and this next value that they entered into the display, right? So here we are in perform operation. So let's say I'm actually going to call this thing the next operator. That's where I introduce all my bugs, is when I'm refactoring stuff and I'm changing names. I'm going to pull my operator out of state. So what does it mean that I'm pulling my operator out of state? If I have an operator, what does it mean inside here? That means that I've been here before, right? Because here's where I set my operator state. I've been here before. That means I'm compounding now upon some previous value. So if I've got an operator from before, I'm going to update my value with this one. So basically, I'm pulling the string out of the display. I'm going to parse that. I'm going to save it off. Say this is currently my value. If there was an operator, if there was a previous value. Yeah, this is where the eyebrows start to furrow. Maybe it'll be clearer if I. Maybe it'll be clearer if I did like this. The value is null. Actually, I'm just going to copy and paste some of this stuff. That one. Okay. So if I did not have a previous value, in other words, the value is null, go ahead and save off that value. Otherwise, we have an operator. This is, again, from the previous computation. So we're going to have some sort of default value, and we can use that in our operations. The current value, the input value. This input value is going to be next value. So the thing that I was calling computed value before is this thing. So let's see. So if I type 65.3 divided by 32, and then I hit equals. Oh, whammy. Where did I screw this up? Let's see. Operations, the operator, my current operator, waiting for my operand. Give me just a second. Is it because I'm using JavaScript math?
It's because you're live coding.
Exactly. It's because the demo gods are upset with me. Hold on a second. Anybody see my bug? Oh, thank you. What is my initial state? My initial state is 0 for my value. Talking about here? Oh, I copied this thing. Sorry, in the back? Here? So if my value was null, basically the real value, remember this is a numeric value. My state value, the value, state.value is a numeric value. State.displayValue is a string. So in this case, basically here what it means is no previous value, and they hit a operator key. So like whatever, maybe there's some numbers in the display, and we're just going to save that off as our value. That make sense? I think, hopefully fixing that little typo that I had, I think should help us out here. +6. Ugh.
Where are you saving the current value?
Where am I saving the current value?
On line 10, can you check the values to 0? Because that was your initial state.
Sorry, which line? 82.
82. Instead of value is null. Your initial state's value is 0.
Ah! You guys are awesome. Let's do that. Thank you. 63 plus 3. Thank you. You guys were 63, I don't know, times 9 divided by 8. Not bad.
I don't know if that's right.
Not bad. I wanted to do something else. Notice this display. That kind of stinks, right? Like as you're now like typing stuff, the display just sort of like doesn't resize properly. It's not that great. What does the phone do as you type more and more numbers? The numbers kind of like shrink together, right? Is there a way we could think about how to do that in React using this same idea of what state is there and when does it change? What if we had something like this? What if we had a class called auto shrinking text? Maybe that could do something cool for us. So instead of our display down here, I'm going to render an auto shrinking text. Pass in the display value. And I'll give it a class name too. Keep this class name on there. So lots of times we don't really think about making these kinds of things declarative, because this is a div, right? This is essentially just a div. It's got some special behavior to it. Pass on all of our props, so that's going to pass on our class name and our children props. So this is essentially just doing the exact same thing that we were doing before. Nothing should change in the UI yet. Well, so basically what I want is I want a div that is smart enough to know if it is exceeding the bounds of its parent, right? And if it is, I want it to shrink. And if it's not, I want it to grow. React actually has some really cool lifecycle methods for this. Component did update. So component did update is a really cool lifecycle method that we get to use right after the component updates, after we flush our updates down to the DOM. We actually have the chance to go back and like measure ourselves, right? This is a pretty common trick. So we could say, let's see, I'm going to stick a ref on this thing. Ref node. This dot node equals node. That's a callback ref. So I'm going to say const, let's see, offset width equals this dot node. So I know how wide I am. Actually, let's get just a reference to the node. Okay, so I know how wide I am. Const, let's see, parent width equals node dot offset parent dot offset width. So then I could say scale. So basically, I'm just going to use like a scale transform, right? CSS transform scale. So I'll say the scale is going to be my width divided by my parent's width. So if that's bigger than 1, that means I'm too big, right? That means I'm overflowing my parent's bounds. If it's smaller than 1, then I can just have my scale be 1, and then I'll be full size. So so my scale will be offset width divided by my parent's width. And if that is greater than 1, So 1 is like my default scale, right? So if I'm bigger than my parent, what I need is to scale down. I guess, oh man, it's math. It's like late at night. Let's see. So the offset width, my parent width, so my scale should be 1 minus that. No, 1 over that. Thank you. Well, it's not really good to call it scale, is it? I don't know. We'll figure out a better name for it. Otherwise, I'm just going to set my scale back to 1. Thank you. Let's put our transform in here. Let's see. Yep. I'm going to put these on separate lines, so this is a little bit cleaner. Oh, that ref is missing a equal sign. There we go. So style is going to be transform scale const scale equals this dot state. Am I doing this right, Michael? It's like, man, after the last thing, I have no clue if we're doing this right. Transform scale x, y, right? I think that's how it works. We're probably going to need to like do a transform origin on this thing too, right? We'll figure that out. So now, okay, so I just want to experiment with this thing. So if I punch in a bunch of 9s, okay, it's not working quite yet. Let's see. I'm gonna actually log this. Make sure I'm doing my math right. Pop down in here. Okay. So, oh, geez. Oh, that's why you don't set state in component did update, because you get into these infinite loops. Okay, so what we're going to do is else if scale, I've got to know what, just a sec.
Need to wrap it up.
Yeah, I'll wrap it up. Dot state dot scale not equals 1. There you go. Come on, Chrome. Oh, let me go back to my example over here. Oh, just pass a single value? I'm cheating. Copying all of my code from my solution that I made earlier today in a desperate attempt to not screw this up. Okay, scale is this dot state. Go on with the scale. All right. Never try and do math in front of lots of people. Ugh, it's still not working. Scale, actual scale. The props are basically this is how it's supposed to work, because I got to wrap it up because you guys got to go. So it kind of shrinks down as you. So let's take a look at the solution code. So something like this is actually a really, really interesting problem to model this way. It's something that I've tried to do a lot with JavaScript in general. Is like, how do I, do measuring text and that kind of thing. So if I keep my scale in state, and then I can, I think I was doing the math somewhere off here. If the scale is already what the actual scale should be, just return. Otherwise, adjust the scale and then do the transform. And component did update is actually a really, really cool way to do that, right? Because now you know, okay, the component updated, the state changed, or the state of the DOM changed. Okay, go and measure the DOM. Go ahead and mutate our own state. All right, so that's all I got for you tonight. Sorry I wasn't like flawless. Coding in front of a lot of people sometimes messes with your head. But thank you for your patience. Any questions about any of the stuff that we did, or kind of any of this technique of like, what state is there, when does it change? It's really helped me to think through a lot of stuff. Yeah.
My name's Don. So I have a question about when you're binding the error functions in the render method.
Yeah.
Performance of that, I know you shouldn't be fine, but I still feel like it's creating new functions every time you render. Is that right?
Yeah. So the question is, we're down here in our render, all these click handlers, we're binding those things every single time in our render. So there's a trade-off, right? The only way that I can figure around this is to kind of store some kind of information in the DOM. So if I had like a data value, right? This is what we did in jQuery days, right? I could store some information in the DOM. I could say this is button 0. It's got this data prop. And then I wouldn't have to do the auto binding here. I could just say this.input digit, right? And then so that there's no auto binding anymore. So then in input digit, I could say, okay, what's event.target? That's the button. Pull out its data value out of the DOM. But in that case, though, you have to think about what you're doing is you're actually you're hitting the DOM for that information. So that's slow too, right? So one of the things that I like to do is I like to do this auto binding here in my render. One, because it's convenient. I can just put those values right there and I don't have to store anything in the DOM. Two, did you know that React actually, when you attach a click to any element, a click handler, React only ever actually attaches one click handler to the DOM. So if I'm adding and removing these click handlers, I don't think that's actually causing React to thrash at that level and saying like remove event listener, add a new event listener, remove event listener. I think what it's going to do is React is just going to install one click listener on the DOM. Then when I click, it's going to go to the event target. It's going to find the React class for that. Do you have an on click? Yes. Okay, let's call it now. But it's not going to have to do all of that thrashing as you go. Does that make sense?
Yeah, the way I see it is that it's not the worry about React so much, it's just creating new functions and doing that. My assumption is that you would write this way until you see a problem and then you have to go online and solve a problem.
Yeah, that's how I would approach it too. Yeah.
I mean, and with regard to using the data value type thing, I think that in that case you're still going to define it, right? Because you're still going to access this.
With an ES6 class, you do, yeah.
Yeah. So what I've seen as far as binding there, you can use property initializers. And I don't know how I feel about that. It's a bit strange.
It's the only way around it, I think. Either that or auto bind them yourself in your constructor. I use this a lot. I also use. I also just think arrow functions, like I just use these all the time, all over the place. But yeah, like I just refactored some code earlier today where I was like using the instance property initializers because they only happen once. Yeah.
Any other questions?
Michael Chan.
Okay, so I had a question if I'm super dumb.
No, dude.
With the waiting for, was it waiting?
Oh yeah, the waiting for operand. Yeah.
Yeah, so I was wondering, would there be a disadvantage to kind of like inferring it from the operand state? Right? Like, so
Yeah. So you're saying I've already got this piece of state.
Yeah.
The fact that I've got an operator. Could I instead of, so we've got 4 pieces of state right now in this calculator, could we only have 3, right?
Right, yeah, I guess. Or is there a disadvantage down the line? I kind of missed that end.
No, I don't know. I think that could work. Yeah, I think you could probably eliminate that piece of state and then just derive that. Because that's the goal, right? The goal is to like not keep anything in state, or not keep basically any duplicate pieces of information in state, right? So anything you can derive later, get that out of your state. And I think that might be something that we can derive later, yeah. Except for, I don't know, this piece of code comes to mind, right? This where we're up here and we're setting it false, and we're not actually setting the operator.
Yeah.
You know? These are tricky, like these questions, but that kind of indicates, like, so what would I set the operator to in that case? I'm not 100% sure.
Read faster. Okay. Anybody else?
That's a great question, though.
Other question? All right.
Thank you so much.
And let's give it up for Michael Jackson for having the nerve to live coding for me. That's pretty awesome.